So in today's lesson, I'm going to be teaching you about how to factor a perfect square trinomial. But before we can get to that, I need to explain to you a little bit about what I mean when I say a perfect square trinomial. So to help illustrate that, I have a picture here of a diagram of a square, and I can tell it's a square because each of the sides are identified as being equivalent due to that hash mark. So I know that if one side of this square has an expression equivalent to x plus 2, then I know that all of the other sides have the same expression. So for the sake of just making sure that that's clear to all of us, I'm just going to write that in as x plus 2. So when I say in the statement at the beginning that a perfect square trinomial results from squaring a binomial, this is what I mean. Well, I know that area is equal to length times width, right? And I could even, say that if in the case of a square, I really just have that area is equal to the length squared. But in this case, I'm just going to write in what the length and the width are, and they're x plus 2 and then x plus 2, right? The length and the width are the same. So one could simplify that. I could have initially written that in a simplified version as x plus 2 all squared, right? So when I say a perfect square trinomial results from squaring a binomial, this is what I mean. Now, if I were to, let's say, for instance, go back and take this original expression and just FOIL that out, let's see what we get. So, of course, the FOIL method, first, outside, inside, last. So multiplying my first terms together, that would be my x and my x. That will give me an x squared. Oops, I'm not sure what I've done here. Let me just get rid of this. Got a little too eager. I would have x squared. If I multiply my outside terms together, then I end up with positive 2x, so plus 2x. I'm going to go ahead and do that to my inside terms, so that will give me plus 2x. And then finally my last terms with each other, so that's the 2 and the 2. So that will give me plus 4. So now I'm just going to simplify that. X squared plus 4x plus 4. All right, so in today's lesson, what I'm going to hopefully help you to identify is when it is that you have a perfect square trinomial. So this would be my perfect square trinomial. And if I recognize a trinomial as a perfect square trinomial, then factoring it is quite simple. So let's take a look at that. Now, I'm going to begin by saying, first off, that, this is a useful trick, but it's not essential to know. But it is part of the curriculum, so we are going to talk about it. So, I see this as a trinomial that I already know how to factor. It's a simple trinomial. I can factor it using the methods that I already know. Having said that, if you do learn the skills of identifying something as a perfect square trinomial, then you can factor it a little bit more quickly, I want to say. Okay, so to recognize a perfect square trinomial, here are some things that you're going to have to be able to identify. Okay, first of all, you're going to be looking to see that the first and the last terms are perfect squares. Okay, what do we mean by perfect squares? Well, we mean that they have a square root that is a whole number. So let me give you an example of that. So in the last, if I had something like, let's see, x squared, let's say I had x squared plus 8x, I don't like the look of that plus 8x plus 16. if I want to identify to see if this is a perfect square trinomial, I'm looking to see if the first term is a perfect square and also if the last term is a perfect square in that trinomial. And that's assuming, of course, that you've placed it in descending order of degree, as we want to do as, part of our regular math convention. So let's see. Well, what is the square? Is x squared a perfect square? Yes, it is. I know that because the square root of x squared is a nice clean value, and it's x. And I look at 16. Is 16 a perfect square? Well, yes, it is, because I know that the square root of 16 is a nice, pretty whole number. So there. So the trinomial that I presented you in this example is so far looking like it might possibly be a perfect square trinomial because it fulfills the expectations of that first rule. So let's look at the second criteria that makes a trinomial a perfect square trinomial. So I'm going to rewrite that same equation as we had in the last time, that same trinomial rather, x squared plus 8x plus 16. And so the second criteria states that the middle term is twice the product of the square roots of the first and last term. What? So that is confusing, which is why I think this is a great trick if you're sort of really strong at factoring and you want to challenge yourself. So the middle term, so let's highlight that middle term. I'm going to dissect this whole thing. So here's my middle term, is twice. So in other words, 2 times. I'm going to write that down. 2 times, the product. Okay, product means multiply. So twice the product of the square root of the first and last term. So let's break that down. Twice the product, so twice, I've got that piece, of the square roots of the first and last term. So what was the square root of the first term? Well, the square root of my first term was x squared. So the square, or was x rather, so the square root of x squared is x. So I'm going to say 2 times x, and then the square root of my last term, which was 16, has a square root of 4. So if this is indeed a perfect square trinomial, then let's go through that. The middle term is twice the product of the square root of the first and last term. So when I went through that criteria, it looks like I get 8x. And lo and behold, that is what my middle term is. So if I recognize that my middle term is twice the square root of my first term and my last term, and then I have a perfect square trinomial. So because this particular trinomial fulfills the criteria for step 1 and step 2, I would say that absolutely this is a perfect square trinomial. So here's what I would like for you to do. I would like for you to look at the steps that we looked at in that last example and try to verify for yourself that indeed this trinomial here is a perfect square trinomial. I want you to use the criteria above to try and identify, make sure it follows the criteria for being a perfect square trinomial. So pause the video, give that a try. All right, what I'm going to do now is I'm going to just remind us of steps 1 and 2, the criteria, in order to verify that this is a perfect square trinomial. So in the first question, it asked us that to check to see that the first term and the last term, were perfect squares. So let's see. So my first term is 25x squared. So So is 25x squared a perfect square? Yes, it is, because it has a square root that's nice and pretty. And so there we go. I know that 5x times 5x will give me 25x squared. And so let's take a look at the second part of that first step, which is for me to make sure that 4 is indeed a perfect square. I think that part is fairly easy to see. I know that 4 is a perfect square because it has a nice, beautiful whole number square root. So first criteria has been met. Let's look at the second criteria. So the second criteria is, I need to take a really close look at that middle term of 20x. And so you'll remember that I need to say, well, is that middle term 2 times the product of the square root of my first term and my last term? So the square root of my first term we just saw was 5x. Right, that was this right here, and the square root of my last term was 2. So let's go ahead and work that out. So twice the product of the square roots of the first and last term. So that will give me 20x. So now what I'm going to do is I'm just going to go and verify. Well, that was what I was looking for. I was looking for my middle term to be 20x, and it is. Therefore, I've met the criteria for identifying this as a perfect trinomial square. So, if you in fact identify a trinomial as being a perfect square trinomial, then there are some quick tricks to factoring it. So we say that in the math books they will sort of generally speaking describe a perfect square trinomial as having the general form as such. So a squared plus 2ab plus b squared will factor to give us a plus b all squared. We'll see that in a minute. So notice here that the middle term is in fact twice, there's the 2, the square root of the first and last term. Right? Square root of a squared is a, square root of b squared is b. So it's following that convention. Okay, but we also might have, the case where that middle term is a negative value, in which case the factored form will look very much like in the first example, but we're going to see a subtraction between the two terms instead. All right, let's move on to the steps in factoring a perfect. So to factor a perfect square trinomial, these are the steps that I want to take. So the first step is that I'm going to take the square root of the first term and place the first term in the bracket. So I'm always in a perfect square trinomial, I'm always going to have something bracketed and then square, because remember again, that square comes from the fact that it is a square, right? And that two sides are going to be equal to each other. So I'm going to take the square root of the first term and place it in the bracket. And so let's do that. So square root of 25x squared is simply 5x. Let's look at rule number 2. So rule number 2 is take the square root of the last term and place it last in the bracket. So I'm going to take the square root of 4, which we just saw was 2, and place it in the bracket. There we go. Let's look at our last rule. The last rule is, oopsies, that moved and I didn't really want it to. All right, I'm going to rewrite that. The sign between the terms is determined by the sign of the middle term in the trinomial. So what I'm trying to say here is that I'm looking at the sign of my middle term. And so since my middle term is a positive integer, that means that when I'm factoring this trinomial, I'm going to have a positive, an addition sign there. So I've finished. This is all there is to do when factoring a perfect square trinomial. This trick, remember, only works if you have a perfect square trinomial. If you don't, then this factoring method, this quick trick, does not apply. So what I'd like you to do, first of all, is to just try to factor this as a perfect square trinomial. And let's just assume that the question that was given indicated to you that, in fact, this was a perfect square trinomial. So pause the video, give this a try, and then we'll take it up together in a moment. All right, I'm going to go through this. So if the question already tells me that this is a perfect square trinomial, then the factoring is really easy. Just for the sake of us practicing identifying it as a perfect square trinomial, I'm going to say, well, is my first term a perfect square? Yes, it is. I'm just going to do this on the side. It has, so the square root of 16x squared happens to be 4x. Let's look at my last term. Is it a perfect square? Yes, it is. It has a nice, beautiful whole number square root. Now we want to be careful. It says positive 9. If that were a negative 9, well, we know that there is no real number that has a square root for negative 9 in terms of its square root. So couldn't do that. So yeah, square root of 9 is 3. So now for my middle term, I'm looking to say, well, 2 times 4x times 3, that should give me, let me see, 24x, and indeed that is my middle term, so I'm good to go. This is a perfect square trinomial. So now that I know that, I can go ahead and factor it, and the factoring now is easy. I'm just creating my bracket. I know it's going to be a perfect square, and so I'm going to take the square root of my first term, which is 4x as determined. I'm going to take the square root of my last term, which was the 3 as determined, and I'm going to look at the sign of my middle term, which is a negative, to tell me that this should be a subtraction. So there's my answer. The factored form of this perfect square trinomial is 4x minus 3 all squared, and I'm done. Now, there's something else that I wanted to show you that, this is not something that you really need to know how to do. It's just a quick trick. If you do recognize it, it may save you some time. Let me show you what I mean by that. I can factor this just as a regular binomial or trinomial if I really wanted to, right? So let me start that question again here. This again is just a regular trinomial that I can factor in a way that I could have at any other time. So you'll remember that when we learned how to factor perfect square complex trinomials, we would say, well, this is where you can use my quick trick or the decomposition method. I'd still be looking for two numbers that multiply to give me the product of my first and second term, which is, or first and last term rather, which is 144, but we'll also add to give me my middle term, which is negative 24. And so I know that this value is negative 12 and negative 12. You'll notice here that I end up with the same factors, and that should make sense because that just tells me that my brackets are going to be similar. So negative 12 and negative 12. I'm going to use my quick trick rather than the decomposition method. I can see here that my coefficient of my first term is 16. So I'm going to go ahead and I'm going to divide both of these factors by that and then reduce each fraction. This is going to end up being the same fraction. So dividing both by 4, I end up with negative 3/4. And then setting up my brackets, I'm going to have 4x, right? That 4 tells me my coefficient of x minus 3. And then 4x minus 3. And at this point in the question, what you notice is that, both of those factors are the same. So I can simply write that as 4x minus 3 all squared. So at the end of the day, it's not the end of the world if you don't recognize a trinomial as a perfect square trinomial, because you can still factor it the long way. So just to reiterate that last point, if you don't remember the above rules, don't worry. Just factor as a regular trinomial, okay? And then once you factor it as a regular trinomial, you're just going to rewrite it as a binomial squared. This is just a random other example, right? We would want to tidy that up. Okay, so that is it for today's lesson. Here are some practice questions from your textbook that I'd like for you to give a try and see how you make out. And again, if you have any questions, feel free to reach out to me on Google Classroom and I'll be happy to help you.